So this question is from R.S. Agarwal, Coordinate Geometry, Chapter 6C, question number 21. I've also shared all the pictures in the comment section. So given, prove that the points A with coordinates A0, B with coordinate 0B, and C with coordinate 1, 1 are collinear. So we have to prove that A 1 upon A plus 1 upon B equals to 1. So before starting with the question, the formula for the collinear, if 3 points A, B, C are collinear, if A is x1, y1, B is x2, y2, and C is x3, y3, then for all the 3 points collinear, the formula is x1, y2 minus y3. So just for x, it is 1, for y2 and y3, plus x2. Then in the cyclic order, you can write all the 3 terms, x1, x2, x3 in parenthesis, and y2, y3, then y3 minus y1 and y1 minus y2. This should be equals to 0. So here I'm assuming A as x1, y1, B as x2, y2, and C as x3, y3. Let's just solve this up. So let's just substitute the values in formula. A times of, I'm writing down in the parenthesis. So easiest way to fill it up, just write down the values of x first, taking appropriate space, and then fill the values of y. It is given as 0. We are aware of this. They are collinear. So that's why I'm taking the whole condition as 0, and I have to prove 1 by A plus 1 by B equals to 1. So A times of y2 is B, y3 is minus 1, and y3 1 minus y1 minus 0, and y1 is 0 minus B. So whatever the value it will have, it will become 0, and it will be AB minus A plus 0, or positive 1, negative B. That would be negative B equals to 0. So from here, I got AB minus A minus B equals to 0. So now I can write it up as AB equals to A plus B. Or even I can write down as A plus B equals to AB. Now I'm dividing both sides with AB. So this would be A over AB plus B over AB equals to AB over AB. So this will completely got eliminated with 1. B got eliminated with B. A got eliminated with A. So I got 1 over B plus 1 over A equals to 1. And I can now clearly write it up as 1 by A plus 1 by B equals to 1. Hence proved. So in continuation, similar kind of question, just a simple change is there. 3 points are given, PQR. Let's just write it up. P is negative 3, 9. Q is A, B, and R is 4, negative 5. It is given they are collinear, and this is the given information. You can write down given first and then you can write it up. That A plus B is equals to 1. Then we have to find the value for A and B. So as we are aware, collinear, that means we can use the formula. So now I'm not going to mention the formula here. I'm just directly going to substitute the values for x first. 3, taking appropriate space. A 4 equals to 0. So x1, y2 will be B, y3 will be negative 5. So minus of minus 5, it will become plus 5. Negative 5 minus 9. 9 minus B. Let's just expand it up. So this would be negative 3B, negative 15. This would be 9 and 5, negative 14 of A. This would be 9, 4, 36. Or positive minus, plus minus, it would be minus of 4B equals to 0. Now we will, like terms, we can take them. And for A, there is only one term of A, which is negative 14A. Further numbers are here. So negative 3B and negative 4B, it would be negative of 7B. Negative 14A and Positive 36, negative 15, the result would be positive 21 equals to 0. Now I can take 21 equals to 14a plus 7b. Now I'm dividing both the side with 3. So 7 3 is 21, 7 2 is 14, and 7 1 is 17. So I got 2a plus b equals to 3. And given a plus b equals to 1. So can I write this 2a as a plus b? And then I'm going to write this a plus b as 1. So a plus 1 equals to 3. So from here, I got a as 3 minus 1. That means a is 2, and I'm not using equals to. So you can't use equals to sign in same equation twice or thrice. Only one time you can use. So a is 2. Let's just find for b. So we are aware a plus b equals to 1. So 2 plus b equals to 1. So b is 1 minus 2. b is negative 1. So for a, it is 2. And for b, it is negative 1. So these were the asked things. We got the solution.